Hello, everyone. This is Sanjiv Goyal. Welcome to my show, Confession of a Futurist. This show is a very intriguing and interesting show. I bring guests who have done something or they want to do something to solve the problem of 3 billion more people who are going to be the resident of our planet. Our population is expected to be 10 billion. Yes, 10 billion by 2050. How are we going to manage our economy? How are we going to take care of the health? Especially now, we are still going through the pandemic world, COVID world, and we are talking about wave 3 and wave 4. We don't know how long will it take and how mutation is going to go. And food. We have already cleared our oceans. We have cut so many trees, so we have huge problem at our hand. Today I have invited very special friends of mine, Rupam Shrivastava and Ajay Singh.
Hello.
Both of them have 20 plus years of experience in technology as well as investing. They have ran very large fund in billions of dollars, and they are every single day looking for companies, looking for technologies which are solving future's problem. So let's talk to them and get their perspective on the future. Rupam and Ajay, welcome to our show.
Thank you, Sanjeev. Thank you for having us.
So, Rupam, I have a question for you first. You are investing for last 20 plus years. You are an expert of AI and ML. You are constantly looking for companies making the difference and companies which will be around, hopefully, for next 20 years. So that means we are talking about roughly around 2050 or 2040. So would you mind sharing with us your take? How are you picking these companies and how are these companies solving the real problem?
We believe technology will solve major problems, as you mentioned, and we are real supporters of exponential technology. So we believe exponential technology is the solution to our large problems, our humanities.
Rupam, I think it'll be better if for our audience you can define what is exponential, because I don't want to throw just words. So if you can define it, that'll be very helpful.
Yes. So there are two key characteristics of exponential technologies that double every period of time, double every year, 5x every year, 10x every year, or where costs go down, costs half every year, for example, like solar panels. Right? I'll give you some examples. So most of us agree artificial intelligence is an exponential technology, but then there is robotics, there is quantum computing, artificial AR, VR, biotech, crypto and blockchain are more, and a lot of technologies on the healthcare and biotech and biomedicine side. All these technologies are exponential in nature. They double in intensity or they reduce in costs every period of time. So those are the technologies we are most bullish about. Those are the technologies we want to invest in, and to be sure that we have our startups have the resilience that you said, the 20 year sort of a horizon. We want to invest in the smartest people. So it is easy to say we'll invest in AI. It is hard to invest in an AI company that really makes a difference. And for that, we invest in the smartest people in the world. Hopefully, we go to research institutions, to research labs, to professors, to PhDs who are doing cutting edge work in these technologies, in all of these exponential technologies. So that is the area where we start. And then hopefully, given our experience, we would be able to, or we are able to select the best team, the best entrepreneurs who would be able to execute on those, on their grand ambitions. So hopefully that gives you a good flavor of where we start, basically that's the first step, and then a lot goes into selecting really strong companies.
So Ajay, you are Rupam's partner in crime. You have 20 plus of years of experience. You have done extensive work with Samsung Ventures. Samsung is definitely one of the company leading innovation and technology. Can you talk a little bit about what have you seen and what you think our future will look like in next 20 years?
Yeah, thank you, Sanjiv, for the great question. Actually, a lot of people misunderstand when we talk about what kind of technology that we're interested in. As Rupam elaborated, we are more interested in exponential technologies that are jumping across a few generations of growth in a very short span of time, and that's what we fundamentally believe is going to impact 10 billion people, as you pointed out, in the next few decades. So for us, what is more important is to find those exponential technology gems within the world of AI or within the world of robotics. And for that, we have built a system that reads all the research papers, that tries to understand what is in those research papers and try to figure out what kind of innovation is on the path of becoming a breakthrough technology that can reach that exponential growth phase. So for us, finding those entrepreneurs is the step one, and finding the core technology that they are working on and understanding that to a level that we feel comfortable that this can be prepared into a product that can go into the mass world. It is what we are trying to become really comfortable about before we invest in a company. So some of the examples of that. So one of the areas in artificial intelligence, for example, that we are very interested in is common sense reasoning, for example. So in the world of AI, everybody has heard about the names like deep learning, machine learning. That is a great innovation in itself and has done quite well for the global economy over the last decade plus. But now we are slowly getting to a point where we need to take this next leap. And that next leap is what this common sense reasoning is all about. So for that, one of the professors that is in our network is Professor Josh Tenenbaum, who's the head of MIT's Brain and Cognitive Science Center. And he works on building this common sense in a machine. And the concept is that when we see babies, they watch and interact and play. And by doing all those activities, they learn the common sense of what is a table, what is a chair, what is the relationship between a table and a chair. And can we build that common sense into a machine? So that is one area that we are extremely excited about, and we have been learning a lot about
Ajay,
connecting with a lot of people.
Let's go a little bit deeper into that.
Yes.
People talk about empathy and self-driven cars.
Yes.
Can a car decide, because it's going to have a collision, to pick what object? So there are a lot of complex problems we have to deal with AI and ML when we talk about it. But let's specifically talk 3 billion more people. Our economy today is in, I'm not going to say shambles, but it's a very interesting stage. Are we able to manage what happened? Because last 16 months, really catastrophic in terms of what event. If we go 100 years back, what happened in Spanish flu, and today, it's very different. Are we ready for the future, or we need to do something about that, and how AI ML technology can help us get there? So for AI and machine learning, it's all about finding a pattern in the data. And that data 100 years ago when Spanish flu happened wasn't really available. That's why it took humanity such a long period of time to overcome Spanish flu. Now we were able to use some of these modern tools and technologies to get to a vaccine at such a rapid pace of time. So technology has So I have a question here, since you're an expert of AI ML, and I'm going to put you on the spot.
Yes, sure.
People claim that Moderna was able to build vaccine in 2 days. because of the technology. Is it really true?
I cannot comment on that specifically because that's something that I don't know whether they actually did or did not. But I highly doubt that it could all be done in 48 hours in that. But I could comment on the core technology of messenger RNA that has been known for a decade plus now. And there are already generations ahead of that messenger RNA that is already available in the labs. But our scientists are more comfortable with the technology that is already reached that stable state that they thought could be productized into a vaccine, because that was the need of time, to get to the vaccine as quickly as possible. So they went to the platform that is already robust enough that could be converted into a vaccine. But there is circular RNA. There are other kind of technologies that are now available to us that could potentially even eradicate a disease that we have been very hard to eradicate for the last 100 plus years, like malaria, like polio, like all these things are not away from our planet. They're still, so even the current 7 billion people still deal with those. So how do we make sure that the next 3 billion people don't even have to worry about these kind of diseases that are sort of mortality driven?
So you mean to say that today we have technologies available, which of course in research stage and a lot of trials happening. So illness will be optional. Is that what we are talking in 20 years from now or 30 years?
So now we are going towards a little bit of the topic that you mentioned earlier about the health of the global planet. So what we are going towards is almost a renaissance period. We're moving from sick taking care to health taking care. So sick care to health care is the transition period that we are going through. And some of these technologies and unfortunately or fortunately, this pandemic has shown the importance of health to that wider community, including the investors. So that's why you see more investments are going into health-oriented technologies, into biotech technologies. So one of the examples we can give you is an idea called neuromodulation. Neuromodulation is an idea that our human body has nerve fibers that take information from our limbs all the way to the brain and then bring it back. And that's how we feel things. That's how we have pain, and that's how we have diseases, even like Alzheimer's and epilepsies. So could we eradicate all of them by modulating that signal that goes from the nerve fibers to the brain? So now, for the last 20 years, there has been a lot of progress that has happened in that area, and we are connected to some of the pioneers in that technology that are working on actually making that. And for that, if that is possible, every ibuprofen that you take or any paracetamol that you take is just a software app on your neuromodulation device. Mm-hmm. So without putting any chemicals in your body, without having any side effects or any long-term side effects, especially on your body, you can actually get rid of those diseases like Alzheimer's and epilepsy, and even as common diseases like headache and migraines and whatnot. So what we are seeing is sort of, as I described, is a renaissance period where we are entering from becoming a sick care sort of a system to now a healthcare sort of system.
So Rupam, you are an expert of finance. You find next unicorn. That's your job every day. So let's talk about the kind of companies. I'm not looking for the name. Kind of companies will be the next unicorn, and the problems you see in our world, which technology can solve.
Yeah. So I think I would go back to exponential technologies. So if a company has to be $1 billion company, in a short period of time, it better grow exponentially. It better have a technology which is more software. So we prefer software over hardware just because of the exponential nature. It should be scalable by design. It should not need a lot of marketing. It should have that virality element into it. It should be.
Rupam, I want specific problems because most of our audience are, mostly from IIT or engineer background. What they are really looking for is a challenge. So I do agree with the exponential technology. If you can define a problem, the biggest problem you and me see, it is defining the problem.
Yeah.
Once people like us define the problem, there are a lot of people who can solve. So help our audience define the problem. So you and me possibly will invest in these companies or mentor them or help them become, because we are really passionate. Three of us are really passionate about solving the problem of 3 billion more people who are going to be the Earth resident very soon.
Yeah. So we can take it from the top. What do the 10 billion people need? So food, energy, and computational power. Actually, that has become one of Maslow's basic needs. So taking energy, there are huge problems in energy. Reducing the cost of solar panel, of solar energy, it's already lower than coal, but not in every place in the world. So reducing costs of solar panels, battery technologies, so those are problems. So fast charging batteries, longer lasting batteries over millions of cycles. So energy has a problem. Getting energy to the right people, whether it's transportation of energy or storage. We saw what happened in Texas when the cold front came. Their energy system was not resilient enough. As climate changes, energy systems will be even more under stress. So energy is a big vertical. Getting energy to that next 3 billion people in the poorer countries. Then we can talk about computational power, where artificial intelligence comes in. Of course, how AI can solve artificial general intelligence. That's the big holy grail where lots of people are working. I think where a lot of brain power can also go is in quantum computing. So there are companies building quantum computers. Then there will be a set of entrepreneurs who would write programs for quantum computers, because they would not be linear code the way they are in regular computers. They would need a new kind of thinking, operating systems for quantum computers, programs, applications, antiviruses, everything for a quantum computer that exists for a regular computer. That's where a lot of problems exist, and then they need to be solved. And finally, coming back to food and clean water, that's a huge problem today. In the West, we are experimenting with plant-based meats and so on, but then there are poorer countries where even provision of food is important. We know that 1/3 of food goes waste during transportation. How can we reduce that? Whether it's crops that are genetically modified that can withstand a larger range of temperatures, or cooling technologies which are cheaper so that you can transport for a longer distance. That also goes for vaccines. Actually, we needed really cold temperatures. So there are a lot of problems in food and water, energy and computation. Those
Let's talk about one of these. So let's talk about quantum computing. I hear this word for several years now. It's not pretty new. We are all talking it as about it's this like the holy grail of everything and going to solve everything, because now there is no thinking time involved. You put it and give you the answer. So for example, going point A to point B, there is no calculation. You tell it and the computer will solve it, because it already have the answer, just like our brain is already mapped direction from A place to B place. There is no calculation from going to office from here. But if I put it on my Google map, every time it has to calculate. So I get that basic concept. And let's apply that to healthcare and the areas where we believe, three of us believe based on our understanding, it can impact. So you see, will we be able to do DNA sequencing differently? Will we be able to build an mRNA-based technique to develop new kind of vaccine? Where do you see the biggest opportunity, and where our entrepreneurs or the people who want to focus, they go and learn or they start building these companies?
Yeah. So a quantum computer is extremely suited for one kind of a task, which is optimization of an extremely complex system. In those and massively parallel computing. So our computers are great at serial computing. They do quantum computers do parallel computing. In healthcare, the main area where quantum computers will be, or where we think today they would be really useful, is protein folding and protein design. So proteins are extremely complex molecules. Now everyone knows, COVID has a spike protein that latches onto the cell's surface, and that is how it works. And now with quantum computers, you can actually figure out what kind of proteins if we put them on the surface of our cell, will repel the COVID molecule, because the proteins would not be able to latch on. So protein design and protein folding simulations are the forte of quantum computers, because it's a massive optimization problem. And in fact, we have way more proteins in our body, and finding which proteins are good for us in our stomach, if it helps in digestion, if it's in our brain. All those things are extremely important, where currently intractable problems will be solved, as you said, in minutes by a quantum computer, because it is designed that way. So there would be huge healthcare applications, just molecule design, molecule simulation. How would a new molecule react to if we ingest it? Today it's very hard. You have to do tests on mice and frogs, and then bring it onto humans to just see what happens. Quantum computer can simulate all of those outcomes very quickly.
So can you name a couple of companies who are working in this area today, maybe with quantum or maybe just with AI ML, worth mentioning?
Yeah, so today quantum computing is not where we just talked about it. Today we still need to build quantum computers with enough level of fidelity and complexity that they can solve these problems. So today the companies that excite us most are the ones who are working on building the next generation of quantum computers. And it's all a game of qubits. So yeah, as you said, we have heard quantum computers for 20 years. Those computers were working on 1, 2, and 3 qubits. Today we are talking at 50, 100, even more a number of qubits. At those numbers, almost every parallel computing problem in the world can be solved. So the company that excites us most is a company out of Harvard and MIT. So professors from Harvard and MIT have launched this company. It's a company called CAIA. We have invested in CAIA. We believe the founders of CAIA are the smartest people in the quantum computing field. If not the smartest, they're definitely the top 5. And we believe that when they have come together, they have taken their IP of 25 years working at Harvard and MIT. Nice. They have something really special.
Phenomenal going for us, and which is going to save the humanity or change the way we live, I'm assuming. So
yes,
we should invite them on one of our show in future and talk a little bit more about where are they and how are they solving the real problems. Because technology for the sake of technology has nothing interesting. Technology should solve a problem. Yes. It should not be like a solution looking for a problem. It's a problem looking for a solution. So Ajay, back to you. We talked about quantum computing. Rupam talked about 4 key areas where he sees the challenges: energy, computational power, quantum computing, and infrastructure, I'm calling it, which is food and clean water, is 2 key aspects of it. So what is your take on global economy, coming back to the global economy topic, and technology? Where are we and what should we do? And I don't want this conversation to be about crypto or blockchain and other things. What you see as a future 20 years from now? We don't know. We don't have a crystal ball, but we can still predict something.
Yeah, so I think both Rupam and I are very pro technology and very optimist on technology. So for us, we oftentimes think about, in the context of the companies and startups that we meet all the time, and some professors, that what will that world look like in 10 years when these things come to fruition? And we are lucky to have that vantage point that we get to see some of these things coming out of the research labs and getting the shape of a product. So for us, like, it's quite clear that some of these pieces are already kind of fitting together in that mosaic that we see that is gonna resolve in front of everybody. So some of these things that are gonna impact global economy is the fundamental things like you talked about, which is food. 10 billion people, feeding 10 billion people is not easy. And especially with that diminishing food supply and the quality of food and even that land to even have. So some of the technologies like vertical farming or soil-less farming, some of these are going to become the way to do the global economy flourishing. You can think about how to get fresh water. So people right now get groundwater and or even desalination of the water from the oceans. But there are now technologies that can take water out of thin air in deserts and can actually harvest water out. So those are some of the things that we already see is going to impact the global economy. Some of the other technologies that we are thinking about is around how the humanity actually moves from one place to other place, and how that impacts. Rupam and I were talking about this, that few hundreds of years ago, people just lived in the radius of 20 miles. They grew up and died within that 20-mile radius. But now people move around, and that's how the global economy flourishes. So some of these technologies are going to enable faster travel time, more mobility, and all of that is going to impact at a global economy from a top-down way. So some of these technologies could be, as you may have heard of, is like around drones and boom, supersonic jets. Some of these like robotic technology or space technologies are going to kind of come and impact the economy in that global way that is going to enable humanity to move longer distances in a quicker time.
So mobility is definitely one I'm hearing, and I'm so glad you mentioned that. That's one key area. And for our audience, Elon Musk has already shown or paved the path for a lot of us and created this movement, I'm calling it, because building a car is not just a car. What he has done is he has shown that with the power of the will and a little bit of vision, because if you look at it, we had battery-powered cart for 40, 50 years. This is nothing new. He built a better car with the battery power. That's all. Really, if we think about it. But when he started putting his vision of like, it has to be the top notch, fastest, better, can last 1,000 miles with single charge, have a better battery, which can be charged 1 million times. All of that, 1.3 seconds acceleration, 0 to 60. Bizarre, but we can do it. And we are all from Silicon Valley. We are all engineer on this. Most of us are engineer, even if we haven't done engineering. So we have to engineer the solutions for our future.
That's right.
Once again, Rupam and Ajay, I want to thank you for a phenomenal time. There is so much we can do together. And the big message I have for our audience is, this is the time we have to unite. And the reason is not uniting just for the sake of uniting for a cause. And the cause is very clear. 10 billion people. If we don't unite, if we stay fragmented, if we don't connect, we will not be able to solve any problems, because every single problem requires a multidisciplinary skill set. And that is the biggest thing I hear from Rupam, Ajay, and other speakers I have spoken to. Without multidisciplinary skill set, you can't solve the problem. Look at mRNA. Technologies around, a lot of people are doing it. But imagine once we have quantum computing, and even with today's AI and ML technologies, how quickly we are able to develop this vaccine. It wasn't possible without computers. So now you need bioscientists, you need doctors, you need physicians, you need even CDC, you need government, even at the lowest level, every single public servant to collaborate so we can save the world. And it's so complex. But thank you very much for your time. And I'm looking forward for our next show when we can bring you back again and we can talk more about what progress you have made, especially around mobility and mRNA.
Absolutely.
Totally. Thank you, Sanjiv, for having us. Really delightful conversation.
Thank you so much.